Our last section. This is our last section before our test.
God.
Everything we've done is proportions, correct?
Yeah.
Everything we've done is proportions. Guess what? We're still doing proportions. I'm going to just show you some more things that are proportional and how we can use them. So, we have this picture here. What do you notice about this triangle? There's 3 triangles in there, correct? Actually, there's only 2. I want to see the little one inside the big one. Okay? And the bases are what of these 2 triangles? What do those red arrows mean?
Parallel.
They're parallel, right? So they're parallel. So if the bases are parallel, then AM over MB is equal to CN over NB. And I could rearrange those, I could reciprocate them, right? So what that means is it's the side splitter theorem. If a line is parallel, okay, parallel to one side of a triangle and intersects the other 2 sides, then it divides those sides, guess what? Proportionally. Okay, and that's what it says over in the picture, right? So if you want to highlight the picture, you can, that bottom. So these are parallel. MN is parallel to AC. So we know that those sides are broken up proportionally. Make sense? Okay. Oh, I got the other one. I don't have to move it up. Oh, I don't have the bottom, do I? Shoot. Okay, so then we also have the triangle mid-segment. Oh, I can't fit both of them on. Triangle mid-segment theory. And again, well, this one says I have some congruent pieces, don't I? Okay. Well, if I say mid-segment, I'm dividing things in half, aren't I? So shouldn't I have some congruent pieces?
No. Yes.
Yes. Okay, so this says if DG is congruent to GE and FH is congruent to HE, so that means their measurements are equal, correct?
Yes.
Then GE, that line in the middle, is parallel to DF. So if those are parallel to each other, then the other one applies, correct? And yeah, I could use that. And also, GH, that middle piece, is 1/2 of the base. So,
Can you do those steps again,
Yeah.
please?
okay. So if the 2 sides, do you see how GH divides DE in 2 equal pieces?
Yeah.
Okay? And it divides EF in 2 equal pieces, doesn't it? I wish they had that GH more at a slant, because it doesn't have, I mean, well, it's parallel to this one, but like the bases can be parallel. Okay, so it divides it into 2 equal pieces. So if that happens, then I know that GH is parallel to DF. I know that. And then if that's parallel, then everything above applies with the proportional triangles, proportional pieces. But also, we can figure out GH because it's half of DF. So if a segment joins the midpoints of 2 sides of a triangle, then the segment is parallel to the 3rd side and is how much as long? How much is long? Half. So that could be helpful, right? If I don't have enough information to figure out the proportionality side of it, I could use that, can't I? Okay, so we have this big picture. We need to find X, Y, and Z. X is down here on this bottom chunk, right?
Yeah.
Yeah? And, well, I know that ST is parallel to PR, correct? And ST makes that upper little triangle, doesn't it? Okay, so my side splitter theorem says if a line is parallel to one side of a triangle and intersects the other sides, then it's divided proportionally, correct? That's what it says. And I have all the information about ST and above, don't I? I can find, what is this from here to here? What is that? How long is that? 16. How'd you get it?
You had 4 and 12.
You added 4 and 12. And do I have all the information from here to here?
Yeah.
It's what? 12. So I have all the information about the small triangles, so should I be able to find that other chunk down here? Yep. It says it's proportional. That's what the side splitter theorem says. Listen.
Why'd you make the lines?
Because I wanted you to see this whole triangle right here. Because we're not in the Y one. We're not looking at that. We're trying to find X. And to find X, I don't need any of the middle pieces, do I? How am I going to find it? Well, how does the top one say I'm going to find it?
When do you use thrash? When you get rid of that?
How's the top say I'm going to find these two pieces? X plus 2 over X is proportional to what? What's X plus 2 correspond with?
It's equal to PR.
16. PS corresponds to, it's proportional to SQ, yes? Okay, so 16. And X is proportional to what? 12, the QT. Now, could I have written X plus 2 equals X and 16 over 12? Yeah, I could have done it that way as well. And now I just cross multiply and solve it like any of these problems that I've been doing for 2 weeks, correct?
Yeah.
What do I have to remember with this X plus 2? To distribute. Can I reduce 16 and 12 before I go?
Yeah.
So what, 4 and
4 and
3? So this would just be times 3, and this would be times X. So I have 3X plus 6 equals 4X. Subtract 3X, so X equals what? 6?
Yep.
Just using my proportions in different ways. So do you guys want to do, I found Y next. Do you guys want to find Y or Z? Y. Okay. Well, if I'm looking at Y, oh, if this is 6, what does it make this piece right here?
6 plus 2.
It's 6 plus 2, so it's 8. Okay. And it makes this 6. Yes? Okay, and we're looking at Y right here. So UV does what with these two sides?
May I use the restroom real quick?
UV up is what on the left? UV up on the left is what? 12. UV down on the left is what? 12. Because it's 4 and 8. UV up on the right is what? 9. UV down on the right is what? 9. Do you have something that does that? That is what? That's the mid-segment theorem, correct? So what does it say? It says if that happens, what do I know about U and UV and PR? They're what to each other? They're parallel. And I also know that it's what? half. So UV, which is Y, yes, is going to equal half of PR. So it's going to be half of 30, which is what? 15. Now I only could do that because what?
What was you?
Mm-mm. We didn't just say anything about Z. We were only using UT. Because UT was the mid, right? Because UT bisected,
Would it be UV?
oh yes, UV, thank you. Because UV bisected the two sides of the triangle, yes? Bisected PQ and what? What's the other side? QR. So that's the only reason I got to use that. But am I going to have to look at the whole picture? Yes. I get to use some puzzle solving skills. Now what do I have left? Z. So there was Y, right? There was X. We're going to find Z. And I gave you guys enough room, didn't I? I made it more room for you. Okay, well, let's see. Well, I know that triangle PQR is similar to triangle QST, don't I? Don't I know that? So the big triangle is similar to this one in here, isn't it? I know that. So if I know that, how can I find Z? This has nothing to do with today, does it?
No,
Because if I know two triangles are similar,
that's like
so Z over 30, yeah?
equals 30 over Z.
No. You gotta use one of the sides, left or right.
One of them,
Which one?
12. 6.
So you wanna use the right side?
Yeah.
Okay, so the right side,
Or
for
put it
S-
Z,
from STF, the right side is how much? 12. Okay, on the right side, the whole side is what? 9 plus 9 is 18. We've got to be able to piece these things together, right? And you're going to need to draw yourself pictures. When you're in your book, can you draw yourself two triangles next to each other if you wanted to and get them out of it? Yeah. Okay, so you guys want to reduce 12 and 18 before we go further?
Yeah.
2 and 3? It's nice when that happens, right? Times 30. 3 goes in 30 how many times? 10. So Z is what? 20. So are you going to have to pick things out of these pictures?
Yeah.
Yes. Okay, we got a corollary. Corollary means I use the same concepts as before, yes? Okay, well, we don't have a triangle, so we're not using that concept. We're using the concept of what? Look at the pictures.
Lines.
What kind of
Perpendicular.
parallel? We're using the concept of parallel lines again, okay? So this picture says line L is parallel to line M, which is parallel to line N, correct? So all three. Could I extend this more and more lines? Yes. Okay, and we did this with transversals and found angles, but now we're finding sides, not angles, correct? So it tells me then if all these things are parallel, what does this say about this proportionality? AB, which is right here, would be proportional to what? BC. And DE would be proportional to what? EF. Now, could I have written that AB over DE equals BC over EF? Yes, as long as I'm keeping those corresponding parts, either side to side or up and down, right? Okay, so in words, corollary to the side splitter theorem, if three parallel lines intersect, two transversals are lines that go across them, correct? Okay. Then the segments intersect on the let me say that again. Then the segments intersected on the transversal are, guess what? Proportional.
What happened?
Okay. Hopefully, when I copied this, I made your picture better. Can you read it? Can you read your picture, the measurements? Okay. When I first did it, like, it's so small, the shadow, you can't see how the shadows? They made it so realistic, you couldn't see the 60. Okay, so, stay with us one.
I am.
Okay, reflecting pool is separated by walkways parallel to Lincoln Street and Jefferson Street, which are parallel to each other. The city wants to add additional tiling around the pool. How much tiling does X and Y feet represent? So, since these lines are all parallel, are my segments proportional? Yes. So, X over what? X over 24? Okay. Could I put X over 60 if I wanted to write it that way? Yeah. Okay, so what goes across from 6X? 60, and across from 24 is? 72. Well, hopefully you know that 12 goes to 72 and 60, correct? So what is it, 5 and 6 times?
Yeah.
Times 24. So that's my cross product, right? 6 into 24.
Is 4 times.
So X is how many feet? 20. And don't forget your feet. Is that any different than what we've been doing? No. I just told you they're proportional, so now you need to remember that those are proportional and you can solve them that way.
Where do you find Y too?
Find Y on your own. Did you get 144/5?
Yeah, I just got it.
Oh, just got it.
Same.
Yeah.
Okay. So 144/5, and since I'm gonna report this to somebody, I probably need to divide it out because they're not gonna know what that is, right? So 5 goes into 14. How many times?
Twice.
Twice, with a 4 left over. So I now have 44. 5 goes into 44. How many times?
8.
8, with how much left over?
4.
4. So 5 goes into 40. How many times? 8. So 28.8 feet of tiling. Questions? Just know that those sides, right? Just pair it up. The hardest part of any of these problems is making sure your corresponding parts are where they need to be, right? Okay, so another one, last one of the whole chapter. A triangle angle bisector theorem. Bisector means what? Cut and
Cut
sit.
in half.
Okay, so this says triangle UVX. So UVX, so the left side, right, is congruent to triangle WVX. So that's the right side. Says that right?
Yes.
If these two triangles are congruent, then what did this do? It made those angles equal. So we know that UX over WX is equal to UV over WV. Because the congruent triangles have proportional sides, correct?
Yes.
We learned that. That's just what that says, isn't it? So, it says, let's see, if any, yours should say if any over here, doesn't it have like over here? Bisects. Good job. My pen up there does not work nice. Bisects, if any ray bisects an angle of a triangle, then it divides the opposite side into two segments such that the ratio between the segments is the same as the ratio between the sides of the adjacent segments. So basically, it divides the base, right? And it uses the other two sides of the large triangle. We're not using that ray that bisects, are we? We're just using the ray that bisects to tell me I can do it. So what is AD and CD? Well, in order to find AD and CD, I gotta find what? X. And this is 16 down here, if you can't read it. 16. So, does BD bisect angle B?
Yes.
Because bisect means cut in two equal parts, correct? How do I know those are two equal parts?
Because the angles.
Because it tells me, right? The little red line tells me.
Yeah.
Okay, so since that happens, what do I know that I can set up? A ratio. But what am I missing? Am I missing CD? Oh, shoot. I know the whole thing, and I know I have X. So 13 minus X, way to apply what we did earlier. And if it was X and 13, it'd be X minus 13, right? So now I can set up ratios, can't I? Okay. So do you guys want to put above and below or next to? How do you want to do it? Does it matter?
No.
Okay. So x over 13 minus x, does that work? Okay, what goes with x?
Um,
10. What goes with 13 minus x?
16.
16.
And then divide it.
You want to reduce?
Yeah.
By what? 2?
Yeah.
So 5/4. So I'm going to multiply x by 4 and 5 by the quantity of 13 minus x. So I have to make sure I do what with my 5? Distribute it. And I'm going to keep bringing that up because what do you think the biggest, most common error is made? Not to distribute. So put those parentheses and you should always distribute, correct?
Yeah.
Okay, so I have 4x equals 5 times 13 is 65, right? Minus 5x.
And then it would be 9x equals. Did we do it wrong? You have 4 on your.
Yeah, that should be what? 8.
That's what I.
Sorry, guys. I divided the top and the bottom by 2 different numbers. Am I supposed to do that? No. Add 5. X. Is that what I do? So plus 5x. So I get 13x equals 65. Divide by 13. Well, we just multiplied 13 by what and got 65? 5. So x is 5. So now can I find AD and CD?
Yeah.
Okay. So AD is what? 5. And CD is 13 minus 5, so it is 8. Want to try this one on your own? No? How about I just write and you guys do it as a whole? Okay, so what do we, HK does what to this top angle? Bisect it. So I know that my sides are proportional, yep. So what's my proportional I'm going to use?
Would it be like
1/2.
X equals 3. X. And then I need 3x plus 3.
What was that, Carly?
I have no idea.
Also, I can start with 3x plus 3.
But I put x on top.
Well, there's no just x.
well, could we put at the bottom?
Oh yeah, I keep trying to find x.
Oh,
Equals 18.
yeah, 18.
Okay.
3x minus
3x minus 7. And 12. If you always put those whole numbers together, a lot of times you could reduce them, right?
Yeah.
And make my problem easier. So can I reduce those?
Yes.
3 and 2. When I first did this problem, I didn't reduce. That was silly. You want to multiply by 18 and 12. So now I got to multiply the whole quantities, right? So I'm going to have 3 times 3x minus 7 and 2 times 3x plus 3. So what do I get?
9x. I'm doing the.
You're doing this way?
Yeah,
Okay, so 9x
plus
minus
minus
21. Does it matter that I just brought it over to the other side?
20.
No, it don't matter, does it? Okay, and what's the other one?
6x.
Plus 3.
Plus 1 didn't multiply and 1 added.
That's 6.
6.
6.
You didn't multiply, Layden, and she just added them. But the answer is 6.
Subtract 6 over 9.
And add 21.
Yeah.
Do you guys do that all in one step? Have you gotten to the point you're doing that in one step now?
Yeah.
That means we've improved our math skills a little bit. Algebra skills, great.
3x equals.
I don't even know what that is. 3x equals
27.
27,
9.
so x equals 9. So if x equals 9, GH is what?
You do 9 times 3.
9 times 3, which is 27, plus 3 is
30.
30. And GK
20.
is 27 minus 7, which is 20, which if I put those over each other would be 3 halves, which is supposed to be what? 3 halves.
So GK would be 3 halves.
No. Look at your proportions, Carly. Because these sides have to be proportional, right? And the other one was 3 halves, and if you put 30 over 2, you get what? 3 halves. Okay, you guys don't seem like you're, with it today.